This is a water damaged Galaxy S9 Plus that does not turn on, and the customer needs their data that's trapped inside the phone. So in today's video, I'm going to show how I repair this motherboard so we can get the data that's trapped inside, because these newer phones are encrypted. So there's no way we can pull the memory chip off this motherboard and read it because of the encryption. So the only way we can do it is by repairing this specific motherboard, get the device to turn on, connect to the computer, and stay on long enough to back up the data. So this customer needs the usual stuff like the pictures, videos, contacts, texts, notes, all that good stuff, and we're gonna go through all the steps that I do to recover data. And if you need to recover your data from your water damaged phone, reach out to us through my website, which I will link down below. We'd be happy to help. So let's go ahead and get started with this one. So one of the first things I like to do is check what does it do on the USB meter. Now this phone has already been opened. It looks like somebody already worked on it, so that does lower the chance of success, because when somebody else works on a motherboard, you don't know what they did, and it could cause additional problems, including they could cause damage that permanently kills the phone and does not allow access to data. So always be cautious on who you pick for your data recovery. You usually have just one chance to get data from a phone, so pick wisely. We have years of experience doing data recovery, so I hope you guys consider us. So let's go ahead and take a look at what this does on the USB meter. So I have the battery plugged in, the charging port plugged in, the screen plugged in, and then this is my favorite USB meter. I will link to this one down below in the video description. And currently you can see we're getting 5 volts and 0 amps. And we're gonna plug it in and see what it does. And we're getting no signs of life, and we're getting 0.075. So one of the things that I like about this meter is how many digits it has after that decimal. So 0.075. Some meters only have 2 digits. I prefer 3 digits or more, because now you can see a little more information that will be useful for troubleshooting. Now in this case, for Samsungs, it kind of not that important, but for other devices, you can often tell whether there's a problem, because if it says 007 versus 000, that could tell you 2 different scenarios. So this is why I like this meter, so check it out. It's linked down below. But yeah, basically no signs of life. I'm also use the power button, which power button on this one, you do have to press the board into the frame, and nothing, no signs of life. So definitely not powering on. Like I said, this is a water damaged phone, so let's get the motherboard out and inspect it further. So let's inspect the actual motherboard to see where the water damage is. So for water damage, one of the things is I don't like to ultrasonic these motherboards, because what that really does is wash away all the evidence of the water damage, because that's where we want to focus. Water, it does not play well with electronics. So if you could find where the water damaged the circuitry, that's where you would focus on repairing, checking for shorts and stuff like that. And so far, this looks very, very clean. No signs of issues here. Now this is where it gets a little funny looking. So you can kind of see how like this looks a little dark. Now you do have to know what a known good board looks like, so you know what a bad one looks like, and that does come with some experience. And you can see it actually kind of looks like maybe the connector's been replaced. This looks a little weird. This pad right here is missing. Definitely doesn't look good, but the rest looks kind of okay. If we go further down over here, all right, this is where it gets pretty ugly. You can see some caps here are really nasty looking. This chip kind of has like a kind of coating to it, and oh, look at that, it looks like flux here. So definitely somebody has been here. Not a good sign. Wonder what they're doing in here that required flux, because if you know how to do data recovery, this is not a proper step to take, but whatever, let's just keep going. This one looks really bad. So all these caps should have here. Actually, I do have a donor board here I could compare it to. So this is a non-water damaged board, and you can see the difference. You can see how these are shiny and silver. I already have this removed and it looks like it's a wreck, but you can kind of see the difference of what a non-water damaged motherboard looks like compared to this customer's phone. So yeah, it looks like the water damage seems to be concentrated in this area. Now I do want to check the housing. Now I don't know if this is the original housing or not, so I'm going to check to see. You kind of see some possible, it looks like tool damage. This looks like corrosion. Charging port looks clean, that's good. Just so clean. So hopefully the screen is good, because I don't believe I have a known good in stock. But if you want to donate one, feel free to message me. I could always use a broken screen for testing. All right, let's see. So let's check the rest of the board out. And there's some stuff here which usually points to water damage, but it looks pretty clean. This looks all kind of factory. Now this looks a little funny. What is this? Who knows? All right, now there's a giant shield here. Underneath this is the PMIC, which is somewhere around here. There's a few other chips here as well. So unless we have to go in here, then I'm gonna leave it as is for now. I can kind of peek in here on the side. I don't see any signs of water damage per se, but who knows? We won't know until we start working on this further. Now this is where the charging IC is at, and the CPU and the memory. This actually came off really easy, so looks like somebody must have been here already. Hopefully didn't apply any heat here. So this is the CPU and the RAM. This is the UFS, where the memory, this is basically the memory chip, which is technical term of the UFS, which is where kind of like the hard drive of the phone. And this is the CPU and the RAM. So you need the CPU and the UFS, the original ones. If you ever run into a scenario where the motherboard itself is physically broken, or you can't figure out what's wrong with the actual board itself, you can then transplant these chips onto a working board and get the data that way. Although that's always considered a last resort. Like, don't jump to that as a first step. Too many people don't know how to fix existing motherboards, and they jump to what is called a CPU swap or CPU transplant, and then which is really risky to do, and you basically kill the chance of data recovery, because if you mess that up, then you mess up the important chips. So something to keep in mind. Now I do have a video of that on my channel for LGV50, so look for that. But yeah, all this looks clean. I don't see any other water damage anywhere else except for that part that I showed you. This side over here. Now there's no way to look inside. There's a tiny little window here. Maybe we can take a peek in here as well. That looks like just underfill, which is kind of like I don't know, actually it looks a little funny. Definitely underfill, but you kind of see some other gunk in there, so who knows. We'll have to wait and see if fixing this doesn't solve it. So one of the things we can do is, if you're not sure where the issue is, you can use a mini power supply to test this out. So this is the motherboard. This is a DC power supply. When you push power, you enable 4.2 volts essentially, and then amps. So this is not a USB charger, even though it's USB ports. It's not a USB charger. You got to plug this into a cable that has a battery connector. So essentially we're gonna mimic a battery and see what the consumption is like. This is the Mechanic iBoot cable kit. It comes with a million different, has 4 of these with different Android plugs. And the one we need is, for this model, is MC8. Looks like this. Now I use this so much that I have broken the flex. So I had to resolder it back together. I even added a little metal plate for stability. But it looks like this. So this end goes to the board, and this other end provides the power to the connector. So now if I turn this on, I now have 4.2 volts here, which is basically like plugging in a battery. So first now these connectors are reversible, so keep that in mind. If you don't know which one's positive or negative, you have to try both sides. So, restart it. Yeah, so you can see as soon as push power, I get 3.3 amp draw, which is not a good sign. Now that could be because I have this backwards. So let me unplug it, flip it around, and then let's try again. Look at that. So now we only get 47 milliamps. So 0.047 amps. This is significant because we know we're on the right orientation because you're not getting a full short. If you had this backwards, you would 100% guarantee to have a full short, like 3.3 amps. But if you have it in the right way and you don't get, basically one way you will for sure get, high amp, 2-3 amps. The other way is where the correct way you can get the same thing, but you could also get something else. So in this example, we only get 50 milliamps. So I hope that makes sense because now we're gonna go to the next step, which is thermal camera. So this is my thermal camera setup. It is a Seek Compact Pro, my macro lens, my Seek stand, which I will link in the video description. And you should buy one if you wanna support the channel. All right, so let's go ahead and record a video of this. The goal here is we have a small leak of 50 milliamps or so. Although I noticed on Samsung phones, when there's a VCC main short type of short here, it actually limits the current to only 50 milliamps. So that could be part of what the charging IC does, but just something to be aware of. So while we have this short, I'm going to scan the board, so to speak. Since you run the board on the thermal camera, see if we can spot the source of the heat. Oh, there's some heat there in the corner. Although I don't know if that's just a reflection. Let's flip it over. That's weird that that's showing us heat. But there's no circuitry there, so I don't think that's it. Let's, oh, look at that. So you see heat here on the charging IC. That's actually normal. So basically the charging IC handles three things. It comes the battery connector, the charging port, and the main power line. So depending on the scenario, it might feed voltage to the battery connector to charge it, or it might feed it to the main circuit to power that. So it's a little complicated, but it's normal for the charging IC to show heat when you're connected to one of these because you're feeding through the battery connector, through the chip, and then out to like the VCC main equivalent on Samsungs. So keep that in mind. Don't just see heat and assume automatically that's your issue. All right, so far I'm unable to find the short, and this actually disconnected. Let me plug it back in. I checked most of the boards, although 50 milliamps is a very small current draw, so keep that in mind. Sometimes it's hard to spot. Also, metal shields will reflect on the thermal camera and look like it's heat, but it's just a reflection, so keep that in mind. All right, so I'm not able to find the short just like this. So let's go back under the microscope and do some further checking. All right, so because we can't find it like that, let's start measuring around to see if we could find the short. So now this is where we bring out the multimeter and we're gonna essentially probe around, see if we could find the shorts and kind of go from there. And I'm using a Fluke 115 multimeter. Thing I like about it is when you put it in diode mode, you get a long beep when you short the pins together, or if you touch ground and ground. See, that's not ground, ground, right? So that and that are equivalent because we're connected through here, and then through the ground we connect through here. And then you get a short beep when you get a reading between 100 and 850, and by that I mean 100 and 850, and you get no reading if it's still OL. So it's a good, easy way to use audio cues to know whether you have an issue. So OL, short, reading. So keep that in mind because I don't know if you guys can hear that, by the way, but we're gonna probe around for shorts. What that means is red probe on ground, which is this metal shield, and then I'm just gonna probe different capacitors to see if there's any shorts. So we get readings, right? All this looks fine. Let's go on this part. Let's probe around here. So essentially what I do is if I hear a beep, a short beep on one side, the other side is likely going to be ground when you're dealing with the capacitor. This is basically what you should expect. If you get something else, then maybe you found your issue. So this is where the experience and knowledge of knowing how to work on these comes in. Oh, look at that. This one is short and short. So let's keep an eye on this. This one doesn't look like a capacitor. It kind of looks like a coil inductor kind of thing. All right, so keep that in mind. Let's probe here. Short, not short. So usually if I hear a short beep on one side, I just skip measuring the other side, because what I'm looking for is really something that shows short on both sides. Oh, look at that. Here's another one. Oh, look at that, another one. So basically all that's reading as short, let's see, short, and that one looks pretty bad too. And I'm actually measuring where, in my experience, are the most common places to find shorts. This cap even just kind of came off. So let's just get this out. Yeah, this one loose too, so just get it out. Yeah, see the lines here are shorted as well, not shorted. This might be that looks like an antenna line, so I'm gonna ignore that. Not shorted, not shorted. Yeah, see, so there's some places that are possibly short. So let's take a look to see what that could be. All right, so this is ZXW. This is a board view software. So if you're gonna do any kind of board level repairs, you need to buy this. It's like 65 bucks a year, and it's definitely worth it. So here under Samsung on the left, went to Galaxy and then S9 Plus, and this is the G9650. Now technically we have a 965U, but 9650 seems to be the U version, which is the US version. The F version is the international, European or whatever, basically not non-US, which has a slightly different layout. So if you can find the US version, use that, because now you'll be able to see the board you're actually working on. Otherwise, chips are slightly in different positions, caps are in different places. So let's take a look. If you remember, this cap right here was reading short, which also connects to technically this cap through this filter. This line was shorted, so it's pretty much looks like it's all the same line. Now there was a cap here that was shorted, but it actually looks like a different layout, so I'm just gonna ignore that. Let's try to see if we could clear the shorts that we found so far. So what I'm gonna do here is actually gonna use my DC power supply to inject voltage into the board. Now these probes are not my multimeter. These are my DC power supply. So I know from experience that that line is basically the main power line. So I could use 4.2 volts, 2.5 amps. I'm gonna turn it on, and you see if I short these together, we get 2.5 amps. So that's what we're gonna do. We're gonna inject voltage into this line, and then we're gonna use the thermal camera to see if we can spot the short. Because essentially when there's a short, that means if you inject voltage into the line, the cause of the short will heat up. So I'm gonna use those caps, those two caps that fell off, I'm gonna use those pads to see if I can inject. Oh, look at that. So I'm injecting, and you can see how my DC power supply corresponds with that spike in heat. So what I'm gonna do is actually move this in closer. And one of the things about using a macro lens and a seek stand is that you're basically hands-free operation of this. So you can easily adjust the height and adjust the focus of the lens by twisting it. And now we have a closer inspection of where, there you go, look at that. There's that cap above that chip. So you let it cool off, and you can see right here, right there. So if you look at the actual board and then look at the thermal camera, you can see which cap you're talking about. I recommend you record a video and then do this, and then you can go back and watch the video and confirm the short. Look at that. Look how bright it gets. So what I like to do is pulse it by tapping it really fast, and you can find it better. So now let's find this under a microscope. And yeah, so yeah, it looks really ugly. All right, so one of the things about capacitors is that because one leg is on ground, they're essentially connected in parallel, and you don't need all of them installed on the circuit for the board to work, especially for data recovery. So I'm just gonna pop this off by just twisting my blade. By the way, one common thing that a lot of inexperienced technicians do is they find the line that's shorted, and essentially they find multiple places that are reading as short, like I did earlier, and they assume, oh, that cap is shorted, so I'm just gonna go ahead and remove it. And then they probe somewhere else and like, oh, that's shorted too, and just keep popping off capacitors without understanding that when you have a line that's shorted, the whole circuit reads as short. So it doesn't matter where you probe, not until you remove the faulty component, the true, the root cause of the short, will you actually clear the short. All right, so now that we remove this cap, let's see if the short's gone. So I'm gonna put red probe on ground. This is my multimeter now. Look at that. We have a reading. We went from 000 with the long beep to a short beep with 276. And if we go back and measure everything that we previously read as short, so this is where I was injecting, no more short. Let's see if this thing over here is shorted. No, same circuit. Now this one was shorted too. Look at that. It's all the same circuit. So this cap here, shorted cap, brought down the whole circuit to ground. And that's essentially how electricity works and how things are laid out here. Things are connected in parallel, so they're sharing the same line. If one goes down, the whole thing goes down. So now that that's gone, we're gonna test with the DT880 one more time. Now keep in mind, DT880 is out of stock, does not exist anymore. No one ever makes it. I did make another video on that topic, so hope you guys are subscribed and watching all my videos. Let's see if anything changed. Before we were getting 50 milliamps before we even try to prompt to boot. Look at that, short is gone. We're connected and no more short. Now the moment of truth is actually push the power button. So if we look closely here, this is the power button and it connects to those two pins. Yeah, I don't know if you guys can see that. There's two pins there, contact pins. When you push this button, it shorts these two pins together, which then triggers the phone to boot. So to replicate that here, let's see, this goes like this. So it's gonna be, hold on. Actually, it's up here. So there's two contact pins here that touch those contact pins on the housing. So I'm essentially gonna replicate pressing the button by using my metal tweezers to short these pins together, which should trigger the DT80 to react. So short them, and look at that. We're getting what seems to be normal prompt to boot behavior. Let's see if it keeps going. Pay attention to that, because that's the important thing. Yeah, 500, 700. Yeah, that looks like a booting phone. Now the question is it booting all the way to the home screen? Is it gonna stay on? Does USB work? Does basically everything you need to get this data off this phone, we need to make sure everything functions. So do we have image? Do we have USB? Do we have touch? We gotta see what's going on. So now the question is, are the parts in the housing good? We don't know. I don't have known good, but you know what? Let's measure the battery voltage. I just want to ensure this battery is good. I don't want to also plug in bad battery. So the battery connector looks fine. Now my multimeter is going to volts DC mode. And essentially I just need to touch the positive and negative, which are usually the big pads. So like this one and this one. And 0 volts. So this battery is dead. Now the question is, can we jump start it? So I remember from earlier, the top pin, actually let me check it. So we got to figure out which one's positive, which one's negative. So diode mode, ground, positive. So negative and positive. So here, let's do this. Positive and negative. Minus, plus and minus. So if you consider that, how this plugs in, so the positive is on this side. So when you flip it over, the positive is on this side, this is negative. So what I'm going to do, I'm actually going to use my DC power supply to jump start the battery. So now with my DC power supply, I'm going to inject voltage directly into the battery. And you're going to see that react in the DC power supply current draw. So negative, positive, look at that, we're getting some amp draw. So that's feeding current into the battery to essentially charge it. This is essentially how charging works. You're feeding, electricity into a battery cell, and that's what the charging circuit does. It redirects current from the USB cable into the phone and out into the battery connector and increase the battery juice, basically. All right, so I gave it a few seconds just to see if that is enough to bring it back to life. So let's measure it again. We're gonna need volts mode and multimeter. Now these probes are my multimeter probes. And look at that, 2.8 volts. Now this is not enough to boot a phone. We actually need to go a little bit above that. Now the weird thing is my DC power supply only, I need a better camera system so I could have both on the screen. So one thing you'll notice is I'm only getting 400 milliamps being injected. The higher the amps and volts, the more juice, the more juice going into the battery, and essentially the faster it'll charge. So for now, I can just wait. One thing I have noticed is it's a weird trick. Now I don't know why this works. Maybe it's just my probes. I haven't really messed with it, but I'm gonna use something else. Let me show you guys this. So this is also connected to my DC power supply, and then these are connected to my multimeter probes. So negative to negative, positive to positive, like this. So DC power supply is now connected to my multimeter probes. So if you look at my multimeter, it's detecting 4.2 volts that's coming from my DC power supply. But now if I inject into the battery connector like this, you'll see that, look, the voltage dropped to 3.5. But if I show you my DC power supply, I remember I was getting like 400 milliamps. If I do it this way, and I'm now getting 2.2 amps charging the battery. So this is going to charge up the battery really fast. And really, I just need it above 3.0 for the phone to charge the battery by itself, and I don't have to do this anymore. Or get it above like 3.7 volts so the device actually boots right away. If between 3 volts and 3.7, that's when the phone is just in a low battery state where it just shows like a charging symbol, but no battery percent. Especially on Samsungs, it'll just show the lightning symbol with the circle and not actually show any charging percentage or anything. On iPhones, when you're at 3.0 to 3.7 volts, you have that low battery icon and it's not actually charging. So let's give it a good 30 seconds more and see where we are after we unplug this. All right, so now let's check to see where the battery is. So I'm gonna unplug the probes, the cables from the DC power supply, and then we're gonna check the battery voltage now. Oh yeah, 3.4 volts. So just because the injecting voltage just takes so long, let's take a look at, see if the phone actually boots now, or at least shows charging and signs of life. So for that, we're gonna need our handy dandy USB meter again. And if you remember, we were getting 0.07 amps on USB, and let's plug this in to charge. And we're getting, look at that, we're getting 1.1 amps, and we're getting the lightning bolt symbol. But this is gonna show like that until it gets above a certain percentage. Oh, look at that, it's actually 9 volts now. Oh, we're getting, look at that, we're actually getting 2%, but temperature warning. So it's actually normal because I don't have the back cover. So let me put that on. All right, so one thing I noticed is the back cover has corrosion all over it. So let me, technically it doesn't matter because this is the contacts for, the temperature sensor, which is literally this tiny little nub here. It's like a resistor, I believe, or thermistor or something. There's a tiny little thing needs to be detected by the phone for it to charge. This is a safety mechanism built into the phone. And essentially you gotta lock this in and screw it down so it makes good contact. Assuming this thing is not damaged, it should charge the battery now. All right, so let's check this one more time. Nine volts, 1.5 amps, and look at that, 2%. So let's give it a few minutes. Let's get at least, I like to wait until 5 to 10% to boot it up, because sometimes what happens is when it's at so low, especially for data recovery, and if it's water damage and stuff, sometimes it can have issues where the phone boots up, but as soon as it gets to the home screen, it shuts down because too much juice is being pulled from the battery and it can't handle it when it's that low. So think of it this way, like the threshold to turn on is here and is barely here. So when it turns on, it pulls the power below the threshold and it shuts off. You basically want to create a big enough gap so when it does fully turn on, it pulls it down a little bit, but it's still above the threshold where it stays on. And I hope that hand symbol kind of helps visualize what I mean. Because when you're barely above the threshold, any high current draw from the phone will pull it below the threshold and the phone will restart. And this happens a lot with water damaged phones when it's like 1%, because sometimes there's still shorts on the motherboard that are not cleared, but it's enough to turn on. So you want to give it enough juice so that it can compensate for any abnormal current draw. So let's give it a few minutes and we'll be right back. All right, so take a look at that. We're at 12%. Let's boot up the phone. We got Samsung logo. Now, just because we're here doesn't mean we're successful. You literally have to get the data off of it before we call it a success. There's been countless times where we get this far and then it starts boot looping and no data. Or we get to the home screen and then it restarts. It gets to the home screen and restarts. Like a lot of cases where that happens. So let's see it locked. Oh, look at that. We're now in. We're in. So let's see. Yeah, I mean, so far everything looks to be stable and working. So now it's time to get the data from this phone into the computer. There's a few ways to do it. One is through Smart Switch. Another way is through a tool that I love to use called CoolMuster Android Data Recovery. What you got to do is enable debugging mode, which, there you go, turn it on. And then we plug this into the computer. This is another reason why you want to charge it up past a certain percentage, is because computer can only output on paper up to 500 milliamps, which is very low. It's 0.5 amps, half an amp, which if the phone is drawing more than 500 milliamps, then it's actually going to discharge while it's connected to the computer. All right, so let me show you how I get the data off of it. Now, this is a paid software, it's not free, but check out the links in my video description. I will link to it. It is a really great tool for getting data off a phone. So once you have USB debugging enabled, you open up the tool, you will get this message. Click always allow, click OK. And then the tool will actually install automatically through USB from the computer to here. So just give it a second. It takes a minute or so for it to get all set up. And there you go. You can see we are now, the app is running here, and so is it here on the computer. So from here we could get contacts, text messages, photos, videos, and export them. You could also do here in a Super Toolkit a backup, which will do all that. Although I don't like doing this because sometimes leaves out some data. So I actually prefer to just do it manually, because here I can export the contacts as CSV, which is a spreadsheet. I could export them as a text file. And then export options are CSV, HTML, VCF, and other stuff. I usually do CSV and VCF. And then SMS, same thing, gives you multiple options for formats. So these you can do CSV, HTML, text file, whatever. I just do all three just whatever makes it easier for the customer for whatever their use case is. Some people need these texts for like a court case or something, so they need it in certain formats. So let's give it a second for it to load. And then export here. You know, HTML is basically you could browse the text messages in a web browser, which makes it kind of interactive, a lot easier to browse, because you know these are conversations. And then same thing with the rest, just export them, and then I just export them onto a folder. And then for my customers, I offer Google Drive as a link I could share that has all this data compressed into a zip file. Or for an extra fee, we do a USB drive, essentially whatever size we need, we charge them for that size. So you know, from $20 to $40, and then we load the data on there, and then we ship it back with the phone. But yeah, this looks like a successful data recovery. Another option I forgot to mention is Smart Switch, Samsung Smart Switch. This is an app from Samsung that only allows you to back up to the computer and then load it into another Samsung. If your replacement phone is not a Samsung, then this is not going to work. You require a Samsung device. And the cool thing about this one is you could do it through USB on a computer, or if the phone supports an SD card, you can put an SD card and do it directly in the phone by itself. So you do a Smart Switch backup to the SD card, you plug that SD card into a new Samsung and it works. Or you can do like a USB adapter. So if you get a USB-C hub, plug that in and then plug in your USB device, whether it's a USB drive or SD card with an adapter. You could back it up directly to the phone, directly from the phone that way, and then plug that into the new phone, vice versa. It doesn't matter. You can mix and match. I could get the backup, Smart Switch backup from the computer onto a USB, and then the customer plugs in that USB into their phone through an adapter, and then load the backup through the phone in the settings. So it's very versatile, and that's for people who have new Samsung phone replacements. So you basically go here where it says cloud and account and backups. Now this text is really large, so it's really, you can't see the whole thing, but click on that, Smart Switch, and then I guess you have to download it, so you would need to connect to Wi-Fi on this specific case, which sometimes Wi-Fi doesn't work, so that is a limitation, but just something to consider. Yeah, so he's saying there's no internet, so it's not going to work here. But worst case, you could always download the APK file separately and then side load it, so to speak, as some people call it, to load the app directly onto the phone without internet. That's an option as well. But at least you guys see kind of everything that's involved with this data recovery process. So there you go. You guys saw the full process on what I do to recover data. Now this specific case was minor liquid damage, so it was pretty straightforward. Although just because it was easy this time doesn't mean the next time won't be easy. And sometimes, you know, the visual water damage looks minor, but it just becomes a real nightmare. You know, just clearing the short isn't enough. There's additional work to be done. You got to rebuild circuits, replace ICs. You know, there's a lot of things that can go wrong. Now, for data recovery, we do offer a flat rate because you're essentially paying for a service that is advanced and skilled. Like if you do this the wrong way, you could permanently kill the phone and lose the data. So you're essentially paying for the expertise, the experience, and the process of getting data from the phone onto the computer and then to you. So something to keep in mind, it's not cheap, but it is. We do have a high success rate here. So if you need data recovery service, reach out to me through my website down below. As you can see in the video, we know what we're talking about. We were able to solve this really straightforward. And like I said, we have lots of experience working on Samsung phones, Pixels, LG phones, of course, iPhones and iPads. So I hope you guys enjoyed the video. If you want to support the channel, if you learned something from this video, check out the links down below. I link to my t-shirts. This is a t-shirt you can buy and we get a small commission from it. Check out the data recovery software. We do get a commission from those sales as well. We have a soldering course. So if you want to learn how to solder, if you want a more advanced soldering course, we have a 30-day, a 90-day. We have lots of different options and information. I hope you guys enjoyed the video. I will post my LG V50 CPU swap video right here and check that out. This is a really long video, but we're able to get data in that case as well. So I'll see you guys in the next one.